Hello Year 11. Today we're going to look at experimental methods used to measure the rate of a reaction. But before we do, I want us to start as we start every single lesson with a retrieval practice. So I want to know, what do you understand by rate of a chemical reaction? How can you calculate the mean rate of reaction? I want you to be able to calculate the rate of reaction in this question. The decomposition of hydrogen peroxide released 45 centimetres cubed of oxygen gas in 1.5 minutes. What is the rate of reaction in centimetres cubed per second? And finally, magnesium reacted with hydrochloric acid to produce 90 centimetres cubed of hydrogen gas in 66 seconds. What is the rate of reaction in centimetres cubed per second? So I want you to pause the video now and attempt these questions and then come back when you've done them. Okay, welcome back. Let's go through the questions now. Okay, so what is the rate of a chemical reaction? Well, the rate is how quickly the reactants are turned to products. How can you calculate the mean rate of reaction? Well, you can do it with two equations. Either the amount of reactant used divided by the time taken, or the amount of product made over the time taken to make the product. The decomposition of hydrogen peroxide releases 45 centimetres cubed in 1.5 minutes. What's the rate of reaction in centimetres cubed per second? So the first thing we need to do is convert 1.5 minutes to seconds. So that is 90 seconds. So the rate of reaction is the amount of product divided by the time. So it's 45 divided by 90 gives you 0.50 centimetres cubed per second. Magnesium reacted with hydrochloric acid to produce 90 centimetres cubed of hydrogen gas in 66 seconds. What is the rate of reaction in centimetres cubed per second? So the amount of product divided by time is 90 divided by 66, which gives us 1.36 centimetres cubed per second. So hopefully you were successful with those. Okay, so our success criteria. We're going to look at how we can measure the rate of reaction by timing how long it takes to produce a gas. We're going to look at a method that times how long in a reaction where a gas is made, how long it takes for a mass to be lost. And we're going to look at another one that involves a solid substance being made called a precipitate. So we're going to time how long it takes to form that product. Okay, so these are the three methods. We can either measure the volume of gas given off using a gas syringe, or another method that we'll talk about in a minute. We can use a mass balance. So when a gas is given off, it's going to lose mass. So we're going to time how long it takes to do that. And we're going to measure the colour change and the cloudiness due to a precipitate. So let's look at the first one. So we're going to measure the rate of reaction by measuring the volume of gas given off in a certain time. And this is called a gas syringe. There are two ways that we can measure the volume of gas produced in a certain time. I prefer this way with a gas syringe, but we can also use an upside down measuring cylinder clamped and held with a delivery tube bringing the gas through the water, and we can collect it in an upside down measuring cylinder. So measuring the rate of reaction by measuring the volume given off, well, we have various reactions we can use. We can use magnesium and acid, or any other reactive metal and acid. We can use calcium carbonate, sometimes called marble chips, and acid. Now what we're going to do is we're going to add the magnesium or marble chips to the acid and replace the stopper. The gas will travel down the delivery tube and into the gas syringe or measuring cylinder, like that. Okay, so how does it work? How could we measure the rate of reaction? So I want you to think about it just for a minute and then answer the question. Right, we measure it by measuring the volume of gas given off at regular intervals using a stop clock. So we're going to look at the gas being made and say how much volume is being made every 10 seconds or something like that. So what is an advantage of using the gas syringe method? Right, well, it's very accurate. It's very accurate because you can measure the amount of gas and it's not down to judgment. You can read it off on a scale. Also, it keeps the gas in the gas syringe or the measuring cylinder, and so you're not releasing toxic gases into the atmosphere. Okay, so what is the advantage of using a measuring cylinder method like this? Right, well, again, it's accurate because you've got a scale on it, so you can read it easily and no toxic gases are released. But also the measuring cylinder is a bit cheaper, and so therefore more pupils can do this at the same time. So they can have a whole class of people doing it at the same time. But gas syringes are quite expensive and schools can usually only afford a few of them. Okay, so if we drew a graph of the results from this experiment, what shape would you expect the graph to have? Okay, it would look like that. It would start off at 0 and then the volume of gas would build up. So at first you'd have a fast reaction, then it would slow down, then it would stop. Okay, so that's our first method. Right, let's look at the second one. This is measuring the rate of reaction by measuring the mass lost due to a gas. Okay, so this is the apparatus need. It's very, very simple. A mass balance, hopefully one with a high resolution so that we can really see the differences in mass. A stop clock, because any sort of rate of reaction requires you to time it. And a conical flask. Okay, so this reaction again needs a reaction that produces a gas. So we use the same sort of reactions as we used in the last one, magnesium and acid or calcium carbonate and acid. So we're going to add the magnesium or marble chips to the acid, note the mass at the beginning, and then we're going to take the mass every 10 seconds as the gas escapes through the cotton wool. So if we drew a graph of the results from the results of the experiment, what shape would you expect it to have? Well, it will look like this. Okay, so we've got the whole mass up there, and then slowly it's going to lose mass as we go down. So we have a fast reaction at the beginning, and then it slows down, and then it stops. Okay, so we have two methods down now. We're going to look at the third method. Okay, the third method is measuring how long it takes for a precipitate to form. This is the apparatus needed to use this method. We're going to have a big measuring cylinder, a 50 centimetre measuring cylinder to measure the sodium thiosulfate. We have a 10 centimetre cube measuring cylinder to measure the hydrochloric acid, a conical flask, a stop clock, because we always need a stop clock if we're measuring a rate, and a piece of paper with a cross drawn on it. So how could we measure the rate of reaction? Let's see if you can remember what I've just said. So I want you to pause the video now and come back when you think you've got your answer. Okay, so we measured the rate of reaction by drawing a visible cross under the reaction and recording the time taken for the cross to disappear. What are the disadvantages of this method? I wonder if you can remember from the last method. Right, here's the first disadvantage. Different people might not agree over when the mark disappears because people have different opinions and different types of eyesight. So for instance, if I was looking at it, I might have the time a lot shorter than somebody who has really good eyesight. Okay, but it is down to an opinion and a judgment, which means that it isn't really truly accurate. The second thing is we cannot plot a rate of reaction graph from the results. What are the risks with this method? Well, the gas release, sulfur dioxide, causes breathing problems. This method releases gas straight into the room, and people who have asthma might suffer breathing difficulties and get quite distressed with their breathing. Okay, so that's the three methods. Let's look at some review questions. So I want you to pause the video after I read the questions and then try and answer the questions. So, name 3 experimental methods used to measure the rate of reaction. From which 2 methods can I draw a graph? What is the advantage of using a gas syringe? And describe how to measure the rate of reaction from a reaction that produces a precipitate. So can you pause the video now, and we'll come back and answer the questions in a minute. Okay, welcome back. Right, the 3 experimental methods used to measure the rate of reaction are measuring the volume of gas produced in a reaction, either with an upside down measuring cylinder or a gas syringe, measuring the mass lost in a reaction where a gas is one of the products using a mass balance, and timing how long it takes for a precipitate to be made, something we call a disappearing cross method. Which 2 methods can a graph be produced from the results? Well, measuring the volume of a gas from the gas syringe method and the mass loss method. Both of those can be produced a graph, but the other one can't. What is the advantage of using a gas syringe? You get an accurate measurement and you're containing all the gases, so any gas you make is not released into the atmosphere. Describe how to measure the rate of reaction from a reaction that produces a precipitate. We first draw a cross on a piece of paper, place the conical flask on top of the cross, add the solutions. At the same time, start the stop clock and time how long it takes for the cross to disappear. The quicker it disappears, the faster the rate of reaction, and that's our method. Now, these methods are very important because we're going to use 2 of them in our next screencast, which is our required practicals. Okay, so thank you for joining me today, Year 11, and hope you have a good day.